Let's talk about the divergence and curl of vector fields in R2, okay? So let F be a vector field defined in R2. Its 2D divergence, denoted like this, okay? We're gonna just take this as purely formal for now, the notation, and with that little 2D there, is given by taking this, this vector here, okay? Now this vector is not a real vector, okay? This is not a real vector. Not actual vector. It's just, we'll say just formal, okay? So we just use this, you know, and we say that because you can't just, so the dot product is commutative, but you can't just move these two around and get the, you can't move these two vectors around and get the same expression, okay? So it's not actually a vector, but formally we're going to use it. And you dot it with F, and you get this expression, okay? The curl, likewise, again, we're going to borrow, okay? Here we just borrow z-axis, okay? That's why I put quotes around them. We're just using that as formality, okay? And we're writing it as a cross product. Again, this is just pure formal. Don't forget that 2D. So if you use these formal symbols, you'll end up getting this k hat with that expression there, okay? What the 2D curl actually is that, okay? So if you don't care for the formalism, then this is the formula that you want right there, okay? For the 2D curl for the vector field given here, okay? Now, what's the meaning of these? Okay, I'm gonna write this very broadly just for your intuition's sake. You could say that this is sort of a measure of twistiness of vector field. Okay, that's how much the vector field twists. Whereas the 2D divergence is measure of expansionness, okay? Measure of the expansionness of, you know, it's not a word, but here in quotes, of this vector field. So how much it expands and contracts. The 2D divergence somewhat measures that, and the 2D curl somewhat measures the twistiness here of a vector field. That's how you think about the divergence and curl of a vector field. So let's do a quick example. Here we have, we want to compute the 2D divergence and curl of this vector field in R2. Well, we just apply the formula. And I also will remark here that partial x, will be using more of this notation, is the partial derivative with respect to x, and likewise for y, similar expression. Okay, so you here's the formula coming from there. Here it is, and you just plug in this f. What is f? It's the x component of the vector field. That's that. And g, what is g? The y component of the vector field. Okay, and you take the partial derivatives, and you end up with this expression, okay? Likewise, you could look at the curl. Again, just focus on that formula there. And we get partial x of the y component minus partial y of the x component, okay? And we end up with that expression for the 2D curl.